Hi guys, today we're going to be going over the composition of functions. So what is a composition of functions? Well, that is when we put one function inside of another. Let's look at an example. Say I have a function, f of x, and I have another function, g of x. So if I were to put g of x inside of f of x, I would have a composition of functions. But what does it mean to put g of x inside of f of x? Well, usually with f of x, we put x inside of f of x because that's our dummy variable. But what if instead of putting x into f of x, we put g of x into f of x? Well, then we would just have f of g of x. No, another way to notate this is f circle g of x. But both of these notations are the same. So, what are some extra cases with the composition of functions? Well, say I just had one function, f of x. Can I put f of x into f of x? Well, yes, you can. You can have f of f of x. And this is a composition of functions. We're putting f of x into f of x, which might seem weird, but it's possible. Well, can we do it again? Can we have f of f of f of x? Well, yes, we can. Think about it this way. We have our original function, that's f of x. Now we have a new function that's defined to be f of x. And then whatever that new function is, we'll call it h of x. We're putting that function into f of x again to get a composition of functions. So we can make three compositions of functions, f of f of f of x. Well, how many times can we do this? Well, the answer is actually infinite. But what if I say I wanted to do this 1,000 times? I wanted to have f of f of f of f of x 1,000 times. Well, that would take forever to write. I mean, we don't even have enough paper for that. So how can we notate that? Well, we can write f, with a superscript we can write 1,000, and then of x. And what this means is that we're going to have f of f of f of f of x 1,000 times. And f of f of x is equal to f superscript 2 of x, f of f of f of x is equal to f 3 of x. Now don't think this means f squared of x or f cubed of x or f to the power of 1,000 of x. No, this means we're using composition of functions. If we want to raise a function to a power, we want that power on the outside. So we'd have f of x to the power of 1,000. So these two are not equal. Not equal. So now that we know what a composition of function is and how we can notate it, let's look at an example. Say I have f of x equals 3x plus 1, and g of x equals 5x minus 2. So what is f of g of x? Pause the video and try to figure it out. Did you do that? Good. Let's go over it. First, we have f of g of x on the left-hand side of our equation. And on the right-hand side, we have f of x, 3, and then instead of putting x here, we put g of x, because remember, the value we're putting into the function is g of x, not just x. Now g of x equals 5x minus 2. So this equals 3 times 5x minus 2 plus 1. And that equals 15x minus 6 plus 1, which equals 15x minus 5. And that's our answer. You can see composition of functions is exactly like putting values and expressions into functions. I have a video on that that's linked in the description that you can go watch to get more practice on this. But for now, let's try another problem. Say f of x equals x squared plus 1 and g of x equals x minus 1. What is f of g of x? Pause the video and try to figure it out. Did you do that? Good. Let's go over it. F of g of x, we have x squared in f of x. So in f of g of x, we're going to have g of x squared plus 1. Now g of x is equal to x minus 1. That's squared, and we add 1. And when we expand x minus 1 squared, that's x squared minus 2x plus 1 plus 1. That's equal to x squared minus 2x plus 2. And that's our answer. Composition of functions is really just that simple.